Good morning, dear students. Welcome to this session on prestressed concrete. We are talking about the code procedure for calculating moment of resistance, or the other way, flexural strength. Okay, so we have seen the formulae to be used for the three cases that we have categorized. Okay, so this is what we were talking about for a few sessions in the past. So we started with the formula, which is to calculate the moment of resistance or flexural strength for rectangular section and flange section having neutral axis falling in the flange. Okay, and very next case is to talk about the third one, neutral axis falling in the web or outside the flange. Okay, so for that case we have developed the formula from the stress block parameters by splitting it into two rectangles that is shown in here, and we have discussed extensively in the last sessions. Okay, right, and we have seen some examples also for the first case and the second case. So first case, we have taken a rectangular section, and we have done the calculation part. To read it from table 11, you have to first calculate the effective reinforcement ratio, and for that ratio you have to read these two values from the table 11 of column 3 and 4, and for column 5 and 6, which are two columns both for pre-tensioning and post-tensioning members. Okay, so either 3 5 or 4 6 must be read accordingly the type of beam given in the problem. Okay, so this is what is called effective reinforcement ratio in the second column. For that ratio you have to read all these values. Okay, right. So the second example is again on a flange section, where first we assume the neutral axis to fall in the flange, and we use the simple formula from the IS code, uh, from which you are able to calculate XU value, that means depth of neutral axis, that will tell you whether your assumption is correct or not. So if you are assuming first that the neutral axis falls in the flange itself, and you are proceeding and finding the solution. Okay, so if you take a flange section, right, first you assume that the neutral axis falls in the flange and proceed for solution, and you get the values of FPB and XU from the table. XU value will tell you whether the neutral axis, say for example, if this is 100 mm, the depth of the flange. So any value beyond 100 is going to give you neutral axis position in the web, and any value less than 100, for example, will be having the flange, I mean neutral axis falling in the flange. So this is very clear. You have to assume first the neutral axis to fall in the flange and proceed with the simple formula from the IS code. And once you know XU value, then you can have a conformity that whether the neutral axis is falling in the flange or web. Accordingly, you can change the formula. Okay, right. So let us go to another example for the third case of the neutral axis position. Okay, right. Just taking this problem. A pre-tensioned T section has a flange 1200 wide, 150 thick. Width and depth of the rib or web 300, 1500 respectively. Okay, so there is a flange section again. The high tensile steel has area AP value 4700 square, located at an effective depth of 1600 Okay, uh, steel has effective depth of 1600. If the characteristic cube strength, uh, I mean FCK 40 and steel 1600 FPU according to the IS code. Calculate the flexural strength of the section. So area of pre-stressing steel given 4700 square. FCK given, I mean 28-day cube compressive strength 40 Newton per square. Width of the section is given. Flange width itself is nothing but width of the section, and width of web given, I mean 300. Effective depth of the section given, effective depth of the section given, okay, 1600, and depth of flange given 150. Okay, right. So the section, if you try to draw, this is 1200 and 150 thick, 300 width and 1500 depth. So this 300, this is 300, not to scale, 1500. Okay, right. So effective depth is mentioned 1600. So overall depth of the section is 1500 plus 150, 1650. So 50 is the effective cover. This is the steel location. So from top, it is 1600. The depth of neutral, I mean the effective depth, small d value. Okay, right. Uh, you can again proceed by assuming the because you don't know whether neutral axis falls in the web or flange. So first you have to assume the neutral axis to fall in the flange. Okay, okay. Then what? Calculate APS FPU divided by BDFCK. So this is like AP means 4700 into FP means what? How much? Stress in steel 1600 divided by B 1200. What is effective depth? 1600 again. FCK 40. So for this value, whatever you get, if you read it XU by D value from table 11, okay, and XU, you are going to get definitely greater than 150. Okay, so this part is missing in the textbook. So you do this one, do this part, say that your assumption is wrong. I mean, neutral axis falling in the flange is wrong, and now you go for calculating APW value. Okay, because to read the table 11, you have to change the formula from APS to APW FPU divided by BW DFCK. Right? So where you need APW, for that you need to calculate APF first. So 0.45 FCK B minus BW DF by FPU, textbook notation, I mean code notation. So 0.45 FCK is 40, B is 1200, BW is 300, width of the web, depth of the flange 150 divided by 1600 is the tensile strength of steel, characteristic tensile strength. So that is giving you 1518 mm square as area of steel for flange. Total area is 4700 minus, if you remove, I mean deduct the flange value, you get the steel for web. Okay, this is web steel. Now you substitute 3182 and FP, characteristic compressive tensile strength of steel, BW instead of BW instead of 4700, now 3182 you have to substitute. Depth is again 1600, effective depth FCK 40, so that is coming around 0.265. Now go to table 11, table 11, 0.265. Okay, so this 0.25, 0.3 is there, so 0.265, okay, is close to 0.25, or else I told you to interpolate. Okay, so for no pretensioning, this value you don't have any problem, because it is not changing, it is only 1. So for all values of between 0.25 and 0.3, for all values it is 1 only, so take 1 for this, and xu by d, you shall interpolate between these two values. Okay, so 0.542 and 0.655, so it is somewhere in between these two values. So let us see what textbook has taken the value. Okay, so what he has taken, so 1 is okay from table, he said it is 1, so FPU is 0.87 FY, 1392 is the FPU value. XU by D he has taken 0.56. Okay, so XU value is 896 mm, depth of neutral axis. Now you write the formula, full-fledged formula for MU calculation. FPU APW D minus 0.42 XU, 0.45 FCK B minus BW DF into D minus 0.5 times DF. So substitute all those values. For FPU, whatever you read from table 11 of IS code 1392, APW, which is calculated area of pre-stressing steel for web, calculated from AP minus APF. Okay, APW is equal to this, APW is equal to AP minus APF. Okay, right, so that is APW. D effective depth 1600, 0.42. XU calculated, I mean read from table 11 and calculated XU value 896, plus the moment of resistance from flange. This is moment of resistance from web. Both are added. So 0.45 FCK B minus BW, total 1200, B is 1200, BW is 300. 1200 minus 300, 900 is substituted. DF, depth of flange 150, D, small d, effective depth minus half of flange, depth of flange 150 by 2, 75. So that is giving you, now you can see it here, 5420 kilonewton meter is the moment of resistance from web. Major portion is resisted by web, whereas 3705 kilonewton meter is from flange. So both together 9125 kilonewton meter it can resist. Okay, so this is how we calculate the moment of resistance of the flange section, neutral axis falling outside the flange. And I told you that the textbook is missing that part of assuming not to go to straight away uh, uh, to the case of neutral axis falling in the web, because you don't know, uh, because the neutral axis whether it is falling in the flange or web, always you have to start from the assumption that the you know very well from RCC, you have to start from the assumption that the neutral axis is falling in the flange. Then you will be knowing that it is not correct, your assumption. Then you go to the other case by calculating, start calculating APW value, area of prestressing steel for web. Then go to table and read the tabular values for FP B and XU by D value. Okay, and then you substitute into this formula, which is no written. This formula will not be there in the IS code. You have to formulate on your own. Okay, so this is how we solve the moment of resistance of different sections, like either whether you are given rectangular or the flange sections, anything you can solve for such cases. Okay, right. Next session we'll take up the design for flexure. Okay, right. Thank you.